Good evening, everyone. Welcome to the One Concept per Day portal. And it's the third problem on projectile motion. Earlier, we had done two more problems. Okay, so this once again, one more. Okay, now let us proceed with this. So, this question is taken from May 2002 HL portions. Now, so a girl stands on the edge of a vertical cliff and throws a stone upwards at an angle of 60 degrees to the vertical, such that the stone eventually lands in the stone below. She's standing on a cliff and she's throwing a ball from here. Okay. Now, the stone leaves her hand with a speed of 12 meters per second at a height of 30 meters above the sea level. Okay. So now she's throwing from here. What I will do is I'll pull this one here like this. Okay. Maybe I'll reduce it a little bit, but I will be able to draw it. Now she's throwing from here, so this will go like this, and it will fall here. It will fall at some point over. It falls at this point over here. Okay. Now we need to find what? What is it we need to find? Take the acceleration to be so much, ignoring the air resistance. Determine the maximum height measured from the sea level reached by the stone. Measured from the sea level reached by the stone. What is the maximum height here? This is the maximum height point. You need to find out what is this height. What is this height you need to find? Let me expand this. Right. If that is the case, now what I do is I will draw a line here. I will draw a horizontal line here. Now what does this tell me? This parabola is symmetrical. Okay. This is a normal projectile motion. And from here to here, you already know what is the height. Right. This height is already known to me. What is this height? This is 30 meters. It's already given to me. It's given here. See, look at the arrow here, 30 meters over here. Now I just need to find out this distance y here. Okay, how do I find y? So once I find the value of y, I should just do y plus 30. Don't just write the full only the value of y. I should write this total together. Now how do I find the value of y? So this is normal projectile motion. Y is nothing but the maximum height. So the formula for y is uy square divided by 2g. Now what is u? What is uy? U is 12. See, this is 60, but this angle should be 30. Okay, you should take 30, not 60 over here. Uy, what is your sign? Sine of 30, the whole square, divided by, he has already taken, let us take the value of g to be 10. See, it's given here. Therefore, so here, this should be 2 into 10. It should now be 12 into, what is sine 30 value? Sine 30 is half. So 1 by 2, the whole square, divided by 20. It should be 2 1s are 2 6 are 6 square is 36. 36 by 20, which should be, how much is it? That 2 1s are 2 18s are, which should be equal to 1.8 meters. Okay, so therefore this value is 1.8. So I'll write 1.8 plus 30, which should be equal to 31.8 meters. Okay, so thus the answer here is 31.8 meters. Now you need to write it for 4 marks. What are the steps you need? First is you need to write max height. Max height from sea level is equal to y plus 30. Then the first mark. Second mark is y is equal to uy square by 2g. Then substitution and then final answer. Okay, so this will give you something like how much will you get this? 1.8 meters. This will give you 2 more marks. This will give you 1 mark here. This will be 2 marks. And finally, last one is 1.8 plus 30, which is equal to 31.8 meters. This will give you 1 more mark. Okay, so this is how the marks have been divided. Then the speed at which the stone hits the sea. Okay, what is the speed at which it hits over here? So to this, what you do is, since we already know what is the total height here. Okay, what you can do is you can say, see, if at all the stone comes and hits here with some speed, why does it hit? Because it had some energy. What is the energy? It had an energy equal to mgh. If I take this as a reference level, all the mgh got converted into kinetic energy. You can use that, right? Therefore, use that method. So, because he is asking about speed, whenever this question on speed becomes very easy for you. So, mgh should be equal to half mv square, assuming there are no air resistance over there. No air resistance, so you can use this. So, m goes away. You have v square is equal to 2gh. 2 multiplied by 10 multiplied by height. What's the height? Total height is 31.8 meters. 31.8 meters. So which should be 2 into 318. How much is it? 2 8 are 16, 1, 2 1s are 2, 3, 2 3s are 6, 636 is your v square. Get the value of v here. Value of v should be square root of 636. Let us find it out using our calculator. So we have square root of, oh my god, sorry, 636. The square root of this comes out to be around 25.2. Let me check my calculations once again. If I just did it manually, I might be wrong. So 2 star 10 star 31.8. 636, right? Root of 636 is equal to 25.22, which is nearly 25 meter per second. So why did I truncate it to this much? Reason is once again significant figures. So what are the values that I have taken here? See, I have taken 331.8. Maybe I should convert this into 32 over here. Okay, so in that case it will be two significant figures. So therefore I take 25 meter per second. Okay, now next step. In the space provided below, sketch using the same axis graphs to show how the horizontal and vertical components of the velocity of the stone vary with time from the moment it leaves our hand to just it hits the sea. Note that this is a sketch graph. You do not need to add the values to the axis. Okay, space provided below here in this space. Sketch the same axis graphs to show what axis should I sketch? Is there an axis? Okay, there's an axis over here. So what is this along? This is the y-axis. This is the velocity over here. Okay. Now what is being asked? Show how the horizontal and vertical components of the stone vary with time. This is your y-axis. This is my x-axis. I'll plot like this: vy and vx. Okay, with the velocity of stone. Vertical components of velocity of stone vary with time. Vary with time. How does it vary with time? So vx. What happens to vx? We have seen the similar graphs even in the case of the first problem. This is just a repetition of this. Vx will always, when you throw the ball over here, when you throw the particle over here, you throw it from here, it goes like this and it hits it like this. This is the trajectory. Along the trajectory, now what we'll do is we'll draw the Vx and Vy. So here what's happening? Vx is like this. This is your Vx. And this Vy was this much big. This was Vy. When it came here, what was Vy? Vy was 0. Vx is still the same. When it is at this point, what was Vx? Vx is still the same. But what was Vy? Vy was a little bit higher, like this over here. Okay. Whatever is the length over here, the same length should be written over here when it reaches, because there was no air resistance. So it took the same Vy, and the trajectory should be a symmetrical one. And when it came at this point, what was it? It's much more lengthier. Vy was longer, Vx is still the same. When it reached this point, what was it? This was much lengthier. Okay, the vertical y velocity was too much big. This was Vy and this is Vx. Okay, so this gives you the distribution of Vx and Vy. So it's complete path. Okay, so I think with this we come to an end to the last question also. So before you leave the videos, please do like, share and comment. If you have any ideas, any other topics that you would like to discuss, you can always let me know so that I can make it in the future videos. Thank you.